Okay, and we'll get started. It's 9 o'clock. Good morning, everyone. My name is Sara Schonfeld. I'm from the U.S. National Cancer Institute, and it is my pleasure and honor to welcome you all to the 6th webinar in the series of the ISoRED webinar series on community building in radiation epidemiology and dosimetry research. And today we're thrilled to welcome researchers from the Canadian Organization on Health Effects, excuse me, from radiation exposure, COHERE. We have a pretty packed schedule this morning, 5 presentations. So just really quickly, after each presentation, if there's time for a few questions, we'll invite you to unmute and ask them, or put them in the chat if you prefer. If we don't have time, we'll go on to the next presenter, but again, we would really encourage you to put any questions you may have in the chat. So I won't take up any more time. I'll hand it over to Kristi and Vinita. So thank you and welcome.
Thank you very much, Sara. So it is a pleasure to be here and to provide you an overview on a new Canadian program. But before we do, some quick introductions. I am Kristi Randhawa. I am a Radiation and Health Sciences Officer with the Canadian Nuclear Safety Commission. My background's epidemiology, and I am joined today with Dr. Vinita Chauhan, who is a Senior Radiation Scientist with Health Canada. And we are currently the coordinators of this program. Following this presentation, we will also be joined by some wonderful colleagues and students that will be presenting some of their work. So in this presentation, we will provide an introduction on why we have initiated this program, what the goal, mission, and work plan are. We will also highlight our new webpage and spotlight some activities, and then we will end with the intended impact and outputs of this work. So as a general introduction to the program, COHERE is a joint initiative between Health Canada and the Canadian Nuclear Safety Commission. So both agencies lie within the Canadian federal government, and both agencies conduct and coordinate research on health effects from radiation exposure. Both the CNSC and Health Canada recognize the importance of collaboration and coordination of research on important topics of interest to stakeholders. And this initiative is directed towards a better understanding of the health risks from exposure to low doses of radiation. So interest and activity in low-dose research is continuing to grow in Canada and around the world, and this is to support a better understanding of health risks from low-dose and chronic low-dose exposures where there still remains considerable uncertainty. Due to this global interest and the need for research in this area, a framework for increased collaboration between Health Canada and the Canadian Nuclear Safety Commission was established. So some important considerations. For the system of radiation protection to be effective, it needs to be founded on sound science. So this is where mechanistic data has been proposed to be helpful. This can best be achieved by multidisciplinary approaches that links mechanistic data to epidemiological responses. So to achieve this, we need to consider the following. First would be designing experiments that examine effects of multiple levels of biological organization, technologies that provide high content, high throughput information at lower doses, as well as a holistic approach that accounts from exposures across multiple stressors. This will then lead to a body of evidence that can more effectively support our international radiation protection framework. With that background, we'll now get into some more details about the organization. So COHERE's immediate goals are to investigate low-dose radiation effects and provide accurate and unbiased information on the consequences of exposures to low-dose radiation. to build a national framework for a coordinated multidisciplinary approach and to contribute to a body of evidence under consideration by the International Radiation Protection Framework. We will accomplish these goals by building expertise through maintaining and enhancing proficiency in dosimetry, radiobiology, and epidemiology. By aligning Health Canada and CNSC's research priorities to focus and leverage resources, and disseminating information through informed and consistent messages to the public and stakeholders on matters involving low dose rate ionizing radiation. So currently, the structural framework is comprised only of representatives from the Canadian Nuclear Safety Commission and Health Canada to better align the research priorities between these two agencies. So champions for the program provide oversight to a scientific committee, which is responsible for establishing a strategic research agenda and a work plan for conducting, presenting, and publishing high-quality research. A communication committee contributes to a communication plan, designs and produces promotional products. So those can include things such as newsletters, pamphlets, and also a website presence, which I'll share the link for in the chat. So program coordinators interface with the champions and the scientific and communication committees to ensure that all activities under COHERE are delivered. So currently, COHERE's website is hosted on the CNSC website. Here you can read an overview of the organization, ongoing projects, and our strategic research agenda, which guides our research as well as informs our federal nuclear science and technology low dose priorities. And this website is always being updated. It's a work in progress. So as more projects are added, this website will be updated, and as more individuals are added, we will update that as well. So I will now pass it on to Vinita to provide an overview of the strategic research agenda and to provide some more information on our projects and activities.
So thank you so much, Kristi. Hello, everyone. As mentioned, I'm a research scientist at Health Canada, and I'm happy today to share the ongoing work in partnership with the Canadian Nuclear Safety Commission and a very committed group of professionals. So in this part of the talk, I will describe in more detail some of the priorities and projects that we are undertaking through COHERE. This is effectively summarized in this table, which I will walk you through shortly. So our SRA serves as a framework upon which COHERE can build collaborative relationships and also develop a more coordinated approach, both nationally and internationally. So COHERE's strategic research agenda has identified 5 research themes that best align with COHERE's priorities. The priority areas focus on topics primarily of concern to the Canadian landscape, as well opportunities, tools, and technologies that best leverage Canadian federal expertise. So we have 5 themes currently: cancer effects, non-cancer effects, globalized data sharing and consolidation, capacity building, and epidemiological studies. So in terms of research lines, our focus here is to conduct mechanistic-based research to examine dose-response relationships and links to adverse outcomes. We also want to develop expertise in the area of data management and interpretation, as well as test new technologies and approaches for identifying low-dose response effects and linking these with occupational data to cancer and mortality data. So the benefits of this will be a better mechanistic understanding in the area of low-dose radiation exposures, better communication of risk to the public, harmonization with efforts internationally, and also contributing to Canadian guidance on radiation protection standards. So next slide, please. So with this foundational strategic research agenda, we will address questions of interest to both stakeholders and the public. So broadly, COHERE will help integrate mechanistic and population-based data to support radiation protection and identify new approaches to help interpret early molecular measures to late disease outcomes. So a better understanding in this area will provide more biologically meaningful basis for reliable health risk estimation. So some examples of priority questions include, how does low chronic low dose exposure to radiation lead to disease progression? And what are the key events and interconnectivities? Is the distribution of radionucleotides and the subsequent energy deposition inside a tissue cell homogeneous? Which biomarkers can detect biological effects of low dose and low dose rate exposures to ionizing radiation? And how can these support risk assessment activities? Next slide, please. So more details on priority questions and a list of ongoing projects can be found on CNSC's webpage, but also on ResearchGate. On these web pages, we will also provide information on our research team, expertise, collaborators, both internal and external. So I highly encourage you to check it out. Next slide, please. So in the last year, we have accomplished a considerable amount of work since the conception of the initiative. This includes a finalization of the terms of reference, which defines how we will work effectively together, the management structure, and as well as the work plan. In addition, we have finalized a strategic research agenda, which I just described. We have 14 projects and counting. We are also working towards national low dose coordination, which aims to spark the conversation to bring together all Canadian researchers interested in low dose research. We recently published a vision paper that outlines our vision, mission, work plan, including partners, projects, and international activities. Next slide, please. So now I'd like to get into specifics of some select projects, which we would like to highlight that are underway with CNSC and Health Canada. So beginning with Health Canada, examples of priority projects include exploring the adverse outcome pathway in radiation risk assessment. So for this project, we want to demonstrate international leadership by adopting or adapting the Organization for Economic Cooperation and Development's Adverse Outcome Pathway Framework for Radiation Health Research. So for those of you that may not be aware, the Adverse Outcome Pathway Framework is a means to consolidate existing mechanistic and human studies with the intent to support regulatory decision-making. It has shown promise in informing on knowledge gaps, test method development, and also predictive toxicology. This approach is gaining traction within the wider radiation research community, and we have been instrumental in these efforts. This has included knowledge transfer through organizing international and national workshops, and also developing case examples. So you will learn more on this in the next 3 presentations. As well, we'd like to understand better the molecular initiating events in biological systems from internal exposures to radionucleotides. So to understand that subcellular distribution of radionucleotides, the resulting initial molecular events following deposition to a target organ and follow through to the adverse outcome. Lastly, we want to explore next slide, please. Lastly, we want to explore the feasibility of newer technologies that provide high throughput and high content information, such as genomics and Raman spectroscopy, in combination with benchmark dose modeling, to identify new mechanistic data to strengthen knowledge about the shape of the dose-response relationship for risk identification. So tracking early biomarkers or changes over time following exposure to an agent can provide insight into the underlying molecular changes to the development of pathology, and combined with modeling approaches, they will help translate the information to risk assessment more informatively. So next slide, please. So some examples of CNSC priority projects include the Canadian Uranium Workers Study, which will assess health effects of low cumulative exposures and exposure rates. So this is a cohort study that includes 80,000 workers from Canadian uranium miners, mills, processing, and fabrication facilities. By looking at nearly 70 years of mortality data and 50 years of cancer incidence data, the study will provide further insights into workers' long-term health and relationships between radon and lung cancer. The El Dorado study will assess the risk of different lung cancer histology due to radon decay product exposure using uranium workers first employed from 1932 to 1980 and followed up from 1969 to 1999. So broadly, these studies will parallel ongoing international efforts. Next slide, please. As well underway through the ICRP mentorship program is a systematic review that's being conducted to assess the current state of evidence on how biological sex can modify several radiation-induced health outcomes, including cancer, circulatory disease, cognitive effects, and cataracts. This review will inform the work conducted by the International Commission on Radiation Protection Task Group 111.
Vinita,
Next
sorry
slide,
to interrupt you. I just want to let you know we're almost out of time. Thank you.
Last slide. So to summarize, collaborative undertakings between the two federal agencies will facilitate better use of resources, expertise, and enable effective responses to inquiries and concerns from Canadians. In the long term, this will strengthen the weight of evidence needed for policy development and the improvement of regulation and decision-making to help modernize radiation protection practices. So COHERE will benefit the radiation protection community by broadening international profile, demonstrating leadership, creating a point of contact within the Government of Canada for more effective coordination and collaboration with national and international organizations. Results from COHERE will contribute to the international protection framework, providing that body of evidence, and also the application and incorporation of international recommendations into Canadian regulations and national guidance. Next slide, please. So thank you so much for your attention. So please stay up to date on COHERE activities by checking out the links provided here. Please don't hesitate to reach out to Kristi and myself. Our contact information is provided below, or any of our wonderful scientific team members that are listed here. So thank you again.
Thank you very much. Let's go on to the next presentation so that we can stay on time. And then I hope we'll have some time for questions at the end, or maybe after some of the other presentations. But thank you for a wonderful talk.
Yeah, and we're happy to take any questions afterwards, or can answer your questions from the chat.
Hi, everyone. I'm your next speaker. My name is Julie Burtt. I'm a radiation biologist with the Canadian Nuclear Safety Commission and a proud scientific committee member of COHERE. My talk focuses on how a Horizon-style scan will help researchers use the AOP, or Adverse Outcome Pathway, or AOPs, in radiation sciences. And if Horizon scans and AOPs are new to you, I will define these terms for you during my presentation. And I'll start with a brief intro and conclude with some next steps. The project I'm going to describe to you today is being conducted with the guidance of the NEA OECD, specifically with the oversight of Dr. Jacqueline Garnier-Laplace, and it falls under the umbrella of the high-level group on low-dose research, chaired by Dr. Dominic Laurier. As you can see on this slide, the RAD-Chem AOP Joint Topical Group is one of several groups under the HLG LDR, and this specific topical group is chaired by none other than Dr. Chauhan, who you just heard from, and also Dr. Tollefson with the assistance of Dr. Beaton. Dr. Julie Leblanc and I are the project leads. We developed this topical group to have a forum to discuss, identify, and collaboratively develop joint initiatives. The vision of the group is to demonstrate AOPs as an essential tool to characterize the knowledge domain, define evidence gaps, and ultimately inform research directions based on both chemical and radiation research communities. It's our hope that the Horizon-style exercise will help us achieve that vision by increasing the use of the AOP framework in radiation research, regulation, and protection. Next slide, please. The radiation research field has so many facets, rich with data, from molecular and cellular data to tissue and population level data. The AOP framework can provide an effective way to use data in risk assessment and incorporate it into regulatory decision-making. So now you're probably wondering what's an AOP. Go over that in the next slide. An adverse outcome pathway approach is a conceptual framework. It has predictive utility and it draws from prior knowledge. It organizes data into key events, beginning with a molecular initiating event, leading to an adverse outcome. You'll see on this slide that the molecular initiating event, or MIE, is a chemical. And that's because this framework was first developed for chemicals, and we're hoping to adapt it and use it in radiation research. As I mentioned on the previous slide, AOPs assemble knowledge from all levels of biological organization across molecular, cellular, tissue, organ, individual, and population level data. All types of studies from in vitro, in silico, animal, human, inform the overall weight of evidence, with the intention to build networks that can potentially support regulatory decision-making and are relevant to risk assessment. The framework moves from that molecular initiating event through measurable key events, or KEs, and ends with an adverse outcome. I'm hoping you can start to see how this new framework can organize existing data and allow us to integrate radiation biology and epidemiology to strengthen our weight of evidence for radiation risk. Next slide, please. For those of you who are unfamiliar with horizon scans, it's a method of systematically searching for and identifying emerging trends, opportunities, and limitations that might impact the future direction of a defined subject. For us, that defined subject is the use of AOPs in radiation research. Our project is broken down into 3 steps. We recently completed phase 1. The steering committee reached out to their professional networks to solicit key questions on the use of AOPs in radiation research, looking to know more about people's knowledge, interest, and even hesitation of using this framework. In phase 2 of the project, our dedicated steering committee will sort all the questions we collected and use a best worst scaling methodology, and we'll come together as a steering committee to finalize the top 20 or 30 questions. And lastly, the 3rd phase of the project is where that list of questions the steering committee comes to a consensus on as the top 20 or 30 questions will be sent out to the international community as a survey. We hope to identify what research questions need to be answered first. The information we obtain from this survey will guide the future program of work of the topical group and perhaps give us ideas on possible focused workshops. Next slide, please. In phase 1 of the project, we received 227 AOP related questions. I've used a basic word cloud to show who we've heard from, but with the larger font contributing more questions. And as you can see, Health Canada has submitted the largest number of questions, and this reflects their extensive expertise in leading the world in radiation-related AOPs, as you'll hear from our subsequent talks. Many individuals left their name field blank, so their organization or affiliation is unspecified. And we've received about a dozen questions or fewer from the other agencies listed in the word cloud. And this list reflects questions submitted from North America, all over Europe, and Japan. Although our steering committee is in the midst of sorting our collected questions, we did a quick analysis of the types of questions that we received. And some major themes starting to emerge are using AOPs to better understand the positive effects of radiation exposure, the possibility that AOPs could provide insights on individual sensitivity to radiation, using AOPs to make the link between radiation exposure and the immune system, deciphering the role of epigenetics in DNA damage and repair mechanisms, and demonstrating how AOPs can inform decision-making and support radiation risk assessment. So we're hoping to pull all this information together in a coherent manner to add to the knowledge base of low-dose radiation exposures. Next slide, please. Since this project requires broad participation, as a steering committee, we're trying to advertise it as much as possible, which is why we're here today. I won't read all of the events on this slide, but we've been busy and want to get the entire radiation research community engaged. And if you want to learn more about AOPs, there's also a lot of information on the OECD website that we can put in the chat. I'd like to wrap up with a few key points on what we're trying to achieve with this Horizon style exercise. Indicated at the bottom of the slide, we'd like to identify priority areas for AOP development. We'd like to evolve the OECD program to not just focus on chemicals, but include radiation. We'd like to create an inventory of AOP reviewers. We need experts to help us move this forward. And lastly, we'd like to identify new areas the AOP framework could support. As a nuclear regulator, it'd be really helpful to have an AOP that permits us to make sound regulatory decisions based on a strong weight of evidence that's all tied together in an informative framework across all levels of biological organization. Isn't that the dream? The overall goal is to have a systematic method to gather and evaluate the evidence, encourage collaboration and coordination, and strengthen the radiation protection system with the help of the AOP framework. So with that, I thank you for your attention. Next slide, please. I invite all of you watching today to participate in the international survey. You can reach out to me. My email is here to find out how you can do that. And I'll be happy to answer your questions later on. Thank you so much.
Thank you very much, Julie. We do have a minute or so if anybody would like to ask a question now. I know that Rania had put some really interesting thoughts into the chat. If you'd like, I'll go ahead and read. So and Vinita's answering some of those questions live. Should we go on to the next and then see how we're doing later? Okay, thank you. Go ahead.
Starting at the end there, spoilers. Awesome. Can everyone see my screen all right? I'll take that as a positive silence.
Yes.
Okay, sweet. Thank you. Yeah, good morning, everyone. Thank you, Kristi, Vinita, and Julie for such great background. So my name is Tatiana. I'm a master's student at the University of Ottawa, as well as a research affiliate as part of Vinita's team at the CCRPB. And I'm going to build on what has been said and tell you a little bit about our project in which we are deploying artificial intelligence and systematic review tools in adverse outcome pathway development, so AOP development. And specifically, I'm going to take a look at our space travel case study. And I'm going to try to get through 4 key things. I'm going to talk a little bit about our project objectives. I'm going to talk about our case study. And then lastly, I'm going to go through our systematic review and software tools. And so without further ado, I'm going to start by talking a little bit about our project objectives. So the human body in space, it's not a very hospitable place for humans, and a key stressor of interest is radiation. This radiation comes from the sun as well as from galactic cosmic rays in deep space. On Earth and in low orbit, we are protected by the magnetosphere. However, future missions such as manned Mars missions will be leaving this protected zone, and astronauts will be at a greater risk. So we want to use existing research to characterize the damage of this radiation and also identify knowledge gaps and sex-related differences. And we want to do this in order to best protect those flying into deep space in the future. And so what we want to do is we want to build adverse outcome pathways that link exposure to radiation as part of the complex space environment during spaceflight. And we're linking this to the resulting human health outcome. And with that, I want to take a quick look at our preliminary network. So what we've done is using review articles and subject matter expert consultations, we have created this preliminary network. So we see on the left-hand side, we have our molecular initiating event. This is our deposition of energy. We have a whole slew of key events in the middle, and they all connect to our 4 adverse outcomes of interest that have been identified as as the greatest risk for space travelers. So now that we've collected and created this preliminary network, our next goal has been a collection of the weight of evidence. So when I'm talking about the weight of evidence, what I'm talking about is a collection of primary research that demonstrates a relationship as well as the causal nature of relationship between 2 key events. So here we see I have imbalanced osteogenesis leading to bone remodeling. And this key event relationship in the middle is an example of a place where we are looking for a weight of evidence. And we determine causality by examining the Bradford-Hill criteria. So we have biological plausibility, dose concordance, time concordance, and essentiality. And this gives us an outline of the type of data we're looking for in order to demonstrate the causality of our key event relationships. And so when we're going through and collecting this weight of evidence, this is where we are looking to deploy some of these systematic review tools. So traditionally, AOPs have been built using a narrative approach, which is in which AOP builders, so individuals or teams building AOPs, go out and select maybe key papers in the field or references that support the causality of the relationships in their AOP. But we're looking to augment this approach by borrowing tools from the systematic review world. And so the reason we want to do that is we want to increase the transparency and the reproducibility, as well as reduce the bias that comes with building AOPs. And we're doing this through having a workflow that contains a systematic search of the literature, as well as a traceable flow of references through our workflow or through our pipeline. And additionally, what we want to do is we want to have a blueprint for future AOP builders. So sort of a checklist of approaches and tools that they could use. And this could encourage the construction of more AOPs. And so when I'm talking about systematic tools, there are a couple examples. I could spend, a whole hour just talking about these tools, but I'm going to go through them pretty quickly, and you guys can let me know if you have any questions. So the first is we have predetermined inclusion and exclusion criteria in the form of a PO statement. This comes from a PICO statement in medicine that has now been adapted for use for AOPs. Additionally, our aim is to create systematic evidence maps. So we are going to be visualizing the results of our screening or scoping to characterize the weight of evidence. Our screening flow has multiple screeners, so any inclusion and exclusion has to come from a consensus of multiple reviewers. And lastly, we have a defined and recorded search strategy. And so it's important to note that we are not completing a full systematic review. We are merely borrowing the tools that are of greatest use to AOP construction. And additionally, to help us with this work, we are deploying the use of several different softwares. Oh, sorry about that. So there are two software programs that we're currently using. The first is Distiller SR. Distiller we are mainly using for reference management. It's a great tool to store metadata on decisions on inclusion and exclusion and other aspects of references in a study in a workflow. But additionally, we're testing the AI screening feature. So this screening feature learns from the decisions of human reviewers, and then if deployed is then able to make decisions about other references in the workflow. Again, is it included or excluded? And so we're just testing this feature to see if it has high enough accuracy to potentially replace a second reviewer in our workflow. Our second tool is Swift Review. So it also uses AI to create topic models. And what we're able to do then is to triage the most relevant references. And so this streamlines the number of references that are reviewed by humans. And so altogether, these systematic review and software tools come together into a workflow that looks a little something like this. So we start with our structured search completed by a librarian. We then go on to a Swift pre-screen or triage, and then we go on to our screening completed in Distiller. Again, inclusion and exclusion comes from a consensus from two reviewers, and it is based on adherence to predetermined inclusion and exclusion criteria. And so references that make it all the way through this workflow then go on to be part of the collection of evidence that supports our AOP network. The outcomes of our work are the following. The first is a tested protocol for systematic AOP construction. Additionally, this workflow will be adjustable based on team resources. The second is the network. So our AOP network that will be describing the key health effects of space travel using the OECD framework. And lastly, we will be creating systematic evidence maps that visualize the weight of evidence that supports our space health AOP network. This is a large project and wouldn't be possible without a great team. So I have our team members listed here. Thank you all for all of your hard work. And thank you everyone for your attention this morning. I'm not sure if we have time for questions, but thank you so much.
We do. If there are any questions for Tatiana, please go ahead and ask. There's a number of questions and comments, some of which have been answered just generally about COHERE, and I'm hoping we'll have a few minutes at the end, but please unmute yourselves if you do have a question for Tatiana.
Clear as mud. Yes.
You've all done such a beautiful job. These have been super clear presentations. Thank you. Okay, well, let's go ahead then.
All right. Hello. Thank you, everyone, so much for having me. My name is Snehpal Sandhu, and I'm a third-year co-op student currently studying biomedical sciences at the University of Ottawa. And I've been working on the AOP project at the CCRPB for Health Canada. So I'll be continuing off of Tatiana's presentation and giving a case example on the development of an AOP for bone loss in the complex space environment. Now, just quickly, I'll go over a little bit of background and the literature landscape that we initially found and the associated KEs. Then we'll go a bit into the screening methodology and some of the results we came out with that. So the weight of evidence and study metrics. So since we don't know the effects of deep interplanetary space, our objective is to develop a simplified AOP for bone loss to collate the current knowledge and direct future research to facilitate manned interplanetary missions. The reason we are studying bones in particular is because astronauts in space unload weight-bearing bones under microgravity for extended periods of time, resulting in disuse osteoporosis, where bones become porous and prone to fracture. Exposure to ionizing radiation is also known to result in a similar loss of bone density. So when we first set out our research into the bone loss pathway, we performed an initial literature search to begin developing a preliminary pathway. To give a little backstory to this initial search, we screened around 100 studies relating to radiation and microgravity exposure and the loss of bone mass. From this, we found 74 AOP compliant studies, which formed the basis of development for our preliminary pathway. Then of these studies, 24 looked directly at the effect on humans, simply telling us that there is a significant effect of spaceflight on bone mineral density in humans, as we currently know. So this initial search led us to identifying 3 main cell types involved in bone formation and degradation: osteoblasts, osteoclasts, and osteocytes. Osteoblasts and clasts are directly involved in the deposition and resorption of bone, respectively, whereas osteocytes simply deposit themselves in the bone matrix and serve more of a structural and signaling function. So then with these cell types in mind, we identified many potential KEs or key events that may be involved in bone loss from which we could structure our pathway. And as a quick reminder, a KE is essentially just a measurable change in some biological or physiological parameter that is essential to the progression of an adverse outcome. So with all of these cell types in mind, as well as the potential KEs involved, we drafted this preliminary AOP, which describes the potential sequence of events leading to bone loss after the MIE. The main point of convergence in this AOP is at imbalanced osteogenesis. Imbalanced osteogenesis right over here, which is a KE specific to 2 of the main cell types we identified earlier on, osteoblast and clast. This KE presents as a measurable decrease in bone deposition and increase in bone resorption. Then the KEs beyond this point measure the dynamic tissue level changes that occur in the progression of bone loss to the organ level. So then with this refined preliminary AOP and a more concrete understanding of what the KEs measured, we launched more literature searches so that we could begin to develop a body of evidence supporting or refining this pathway. And just as a quick overview, we employed the use of Swift Review and Distiller SR for our scoping review. Swift was used to perform a pre-screen of our literature searches, essentially triaging our collected references so they could be individually uploaded into Distiller. And then in Distiller, the abstract and full text were reviewed in depth across all 3 levels of screening shown here. Studies were included or excluded based on their relevance to our PO statement. Then, oh, sorry about that. Fully screened articles in level 3 were then used for the collection of evidence and full text data extraction, where data relevant to stressors, dose ranges, and Bradford Hill criteria support, among others, were extracted. This screening workflow was repeated 3 times for 3 separate literature searches into the bone loss AOP. Our first search simply looked for studies examining both the MIE and the adverse outcome, so radiation or microgravity leading to bone loss. The second search looked more for all of the internal KERs in the pathway, so all the KEs leading to bone loss, so that we could catch anything that couldn't be caught by the first search. And then our third search was composed of multiple mini literature searches, each hyper-focusing on a single KER, so that all aspects of the pathway could be covered. Now, to delve slightly into the results of our searches here, I've taken some quick snippets from the different studies we found in the literature searches that serve as representative examples of the changes observed at increasing levels of biological organization. So this came with molecular increases in oxidative stress and changes in osteogenesis and bone remodeling and bone formation rate at the cell and tissue levels, and eventually culminated in a significant loss of bone density at the organ level. Now, circling back to our preliminary pathway, let's take a quick look at how things have changed. And I'll ask that you pay special attention to the KERs connected to increased DNA strand breaks right over here. So you can see now that all of the KERs connected to DSVs here were removed, and a direct KER was formed between the MIE and apoptosis. And this is because we identified in our literature searches that there was a distinct lack of supporting evidence, showing us that there is a knowledge gap in this area of research, at least in bones. And the figure here also shows the quantitative support for each component in the pathway. So each box will indicate the number of studies supporting each KER, while also indicating an overall assessment of the weight of evidence, with green indicating strong support and yellow indicating moderate support. And so on top of the quantity of support, we also assessed different qualities of the extracted studies, such as Bradford Hill criteria and taxonomic applicability. So we can see that the 2 KERs shown here have a very similar spread of Bradford Hill criteria in that they have a high support for dose concordance and essentiality, and a little bit less for biological plausibility and time concordance. So we can also see that while the Bradford Hill criteria spread is similar between the 2, the taxonomic applicability from which this is derived is very different, with one KER having many more human studies than the other, which derives its data mostly from studies in mice. And this shows us a gap in the current knowledge of that KER, much in the same way that we identified a gap in increased DNA strand breaks. And so on top of this, we also collected some data on the spread of stressors examined by studies across the entire bone loss pathway. And with this, we can see which stressors may require more research. And then in this specific case, we can see that more research may be needed for protons and heavy ions effects on bones. All of this to say that collecting this kind of data can be useful in identifying knowledge gaps. And so just to summarize and conclude, I'd like to say that studying the adverse effects of spaceflight and radiation exposure is important for the future of interplanetary travel, especially as the length of time spent in space and radiation exposure outside of the Earth's atmosphere and magnetosphere increase. Further, AOPs are effective at highlighting what the current knowledge is and what knowledge gaps exist in the current literature. And this can help direct future research and inform the development of adequate countermeasures for the adverse outcomes under investigation. And then finally, the implementation of scoping review techniques can be a very effective and efficient way of compiling, reviewing, and refining very large bodies of literature into useful bodies of evidence. So I'd like to thank everyone for listening to this talk today, and I'd like to give a special thanks to everyone on our team and all the consultants and students that work with us, without whom none of this work would have been possible. Thank you.
Thank you very much. Are there any questions for Snehpal? If not, we can go on to Rachel.
All right, great.
Thank you so much.
Can anybody see me?
Can see you. I can see you and can hear you, and we see your slides that Kristi is showing.
Okay, because I'm not, okay. Everybody can, okay, so we're all good to go?
You're good to go.
Yes.
Okay, great, thank you. Hello, everyone. My name is Rachel Lane. I am an epidemiologist at the Canadian Nuclear Safety Commission, along with Kristi and I. We are the PIs for this project. Our project is co-funded with the Saskatchewan government, Cameco, Orano, and BWXT, which is industry. And the analysis will be conducted by the University of Saskatchewan in order to try to increase capacity within Canada to do epidemiological studies of uranium workers. Next slide, please. So as you know, radon and its progeny is produced by the decay of uranium, which is naturally present in rock and soil. Radon gas is released into the air when uranium ore is mined, and to a lesser extent during the production of uranium fuel for nuclear power. From a health perspective, radon is important as it is the second leading cause of lung cancer after smoking, and is the #1 cause of lung cancer in non-smokers. Canada is one of the world's major producers of uranium. Today, all Canadian uranium is mined in northern Saskatchewan's Athabascan Basin. This region is has the world's highest grade uranium deposits in McArthur River and Cigar Lake. The more we know about the health effects of radon exposure, especially at the low levels of today's workers, the better we are able to protect workers and use uranium safely. Next slide, please. Canadian studies of radon-exposed miners have played an important role in understanding the long-term health effects of radon exposure. The Eldorado uranium miners cohort, the Ontario uranium miners cohort, and the Newfoundland fluorspar miners, who were miners exposed to radon in water in their mine. These three cohorts have contributed significantly to the international understanding of radon, with publications since the 1960s. In 1993, the Joint Federal Provincial Panel on Uranium Mining Developments in Northern Saskatchewan was created as a result of development of uranium mining in the Athabascan Basin of Northern Saskatchewan. The panel recommended the need for ongoing health studies of past, present, and future uranium miners. As a result, the Canadian Nuclear Safety Commission, the Saskatchewan government, and the uranium industry co-funded the update of the Eldorado study and conducted a feasibility study of modern uranium miners. Over the last 20 years, the Canadian Nuclear Safety Commission has also updated the Newfoundland fluorspar miner study and the Ontario uranium miners studies, looking at mortality and cancer incidence follow-up. Next slide, please. In 2017, we initiated plans to create a Canadian uranium workers study. This will bring together the historic El Dorado and Ontario uranium miners cohorts, and more recent workers from northern Saskatchewan, and also the Ontario uranium processing and fabrication workers in Ontario. We estimate to have approximately 80,000 workers to study and about 85 years of occupational radiation exposures, 70 years of mortality follow-up, and about 50 years of cancer incidence follow-up. This will be a huge study to improve the precision of risk estimates for lung cancer at low exposures and exposure rates. Next slide, please. The primary objective is to understand the relationship between occupational radon exposure, especially at low cumulative radon exposures and low exposure rates, and lung cancer, both incidence and mortality among Canadian uranium workers. But we will be able to look at all causes of death and many research questions. Next slide, please. The second objectives will be to compare the mortality and cancer incidence rates of the cohort with the general Canadian population. Next, we will conduct exposure response analyses using Poisson regression, in which we will be comparing workers with different cumulative radon exposures. We will assess the impacts of various effect modification on the exposure response relationship. Next slide, please. The National Dose Registry was linked to the Canadian Mortality and Cancer Incidence Database for long-term mortality follow-up in the last couple of years. Our cohort will be obtained through that National Dose Registry. Research team first need to validate the linkages and conduct a really detailed checking and editing of that data, which we are about to undertake now. Once the validation exercise is complete, the data will be provided to the University of Saskatchewan to conduct the statistical analysis. Finally, we will need to initiate a sensitivity analysis. This is because we need to determine the difference between the date of first hire and the date of first monitoring within the cohort. This is important because most epidemiological studies have information on company records, so they have the date of first hire for their start of follow-up. Unfortunately, the National Dose Registry for the more recent workers has only the date of first monitoring. So we need to understand the effect that this may have on our study, and this is one of the things that we're just undertaking now. So if you have any information that could help me on this, I would really appreciate it. Next slide, please. Our goal is to raise awareness of this study to build trust and collaboration with all the different stakeholders impacted by the uranium industry. This includes past and present workers, unions, and Indigenous communities who live in the uranium mines, who live and work in areas around the mines and mills in northern Saskatchewan. Thus, we are translating our material into Cree and Dene, as well as in English and in French. Next slide, please. The Canadian cohort has huge possibilities to better understand the health effects of occupational radiation exposure. It also provides us many research opportunities to collaborate within Canada and internationally. Thank you very much. And if you have any more questions, feel free to contact Kristi or I, or go to the Canadian Nuclear Safety Commission website, and you can look under canoes, and you will be able to read up about the study. Thank you very much.
Thank you, Rachel. There are a couple of questions. Ludmila Lutsko, if you're still on, do you want to ask your question, or would you like me to read it?
Yes, sure.
Okay, so you raised the question to Rachel, have you done or are you planning to check miners of other industries? For example, the potassium industry, where uranium and radon could also be subproducts.
No, we will be looking just at uranium miners. We are actually right now updating a study of the Newfoundland fluorspar miner study. It should be published hopefully in the next year or so. So that is one of the Canadian cohorts that we have been studying over the years. But no, we'll be focusing on uranium miners and as well as uranium millers and fabrication workers. Not reprocessing, the refining and the conversion workers.
Thank you. And then there's another question, looks like was that from you, Rania? What are some advantages of your study compared to PUMA?
Well, I wouldn't say that there are advantages. I would say that two of the cohorts that are in this study, the El Dorado study and the Ontario Miner study, are both a part of PUMA. The difference between our study and PUMA is international, ours is Canadian. We have the PUMA study, the El Dorado and Ontario are from the linkages that have been previously done. This is updated mortality and cancer incidence linkages. Not only will we be including the Ontario and El Dorado, we will be including new, fairly new workers to the study, which we have a large population currently in northern Saskatchewan that have been working and are not included in those two historic cohorts, as well as we have got the uranium refining and processing workers in Ontario that were not part of those two previous studies. Hopefully, in 10 years' time, canoes will be part of an updated PUMA.
Thank you. And we have one more question for Rachel from Omid Azimzadeh. First of all, thank you for the presentation. What type of biomaterials are available? Is FFPE tissue available?
No. No, we are getting information from the National Dose Registry, and it collects information on occupational exposures. The El Dorado and Ontario miners are based on company records from their employee and work histories, but I am not aware of any. I do believe the Ontario miner study may have some biological information, but I won't be involved with it at all.
Sara, are you there?
Okay, thank you very much. I'm sorry, I was needing to drop off the webinar, the next one I'm moderating, because I realized you can't have everything muted, right? So as they started to talk of the other, I panicked. But I want to thank all of our speakers. Rania, is a new hand up?
It is. I was wondering whether I can ask a general question about COHERE to the presenters, the first two at the minimum, if that's okay.
Please go ahead.
I was wondering if you have any sense of public perception of having the regulators, CNSC and Health Canada also guiding low-dose radiation research. How is that perceived by members of the public?
Excellent.
Sure, maybe I can answer from the regulator's perspective. I know we do a lot of outreach with members of the public, and they really appreciate that we do our research, that we have these collaborations with organizations like Health Canada, as well as members from or researchers from various universities. So I think in general, the public perception is good. They are thankful that we are doing this research to inform the health of workers as well as members of the public. I don't know if anybody else wants to add to that.
I will add that the amount of outreach that we do is significant. Working in northern Saskatchewan, where the uranium mines are, we're presenting to them often. And when we're conducting a large research project that impacts them, speaking to them early, involving them in the project. We have a working group and a steering committee that includes a wide range of stakeholders. I would like to think increases our the confidence that we have that we take regulating the industry very seriously, and we want to base it on the best science, as well as involve the communities who are impacted by that industry in our research.
Thank you very much. I know Sara is juggling with 2 presentations. She starts her next webinar at 10 o'clock. So maybe I will make it a bit easier for her and close the webinar by thanking all of you. Excellent presentations and very informative. I definitely learned a lot about this new effort. And I hope to see everybody on November 18th at 9 a.m. where we will be featuring MD Anderson Cancer Center. Early November is when the time changes, so everybody please be mindful when you add this in your calendars, what it means for your own time zone. Thank you again very much.
Thank you.
Thanks, everyone. Have a great day.